So we've been talking quite a bit about parallelograms, and we've talked about properties of parallelograms. So I'd just like to review properties of parallelograms one more time. So the opposite sides, both sets of opposite sides, are congruent. So I can mark that on my parallelogram. My opposite sides, the top and the bottom, and the two sides are congruent. Another property of parallelograms is that opposite sides are parallel. So my top and my bottom sides are parallel, that's what these arrows indicate, and my sides are parallel. Another quality is that opposite angles are congruent. So I can mark that on my parallelogram. Here's some opposite angles that are congruent, and here are two more. So angles that are across from each other on the parallelogram are congruent to each other. Another property is that the diagonals, so there's one diagonal, here's another diagonal, they bisect each other. So they cut each other in half into two equal halves. And then the last quality of parallelograms is that consecutive angles are supplementary. So I'll just mark two consecutive angles, but they can be any consecutive angles as long as they're in a row, not across from each other. They will add up to 180 degrees, also known as they're supplementary. Alright, so we're well versed in parallelograms and we know the different properties of them. And now we're going to talk about special parallelograms, so kind of special cases of parallelograms that have the same characteristics as parallelograms, but with a few extra added twists. So, a rhombus is our first kind of special parallelogram. And what's special about it is a parallelogram, but it has four congruent sides. Okay, so we've got a rhombus. It's a parallelogram, so it has all the qualities of a parallelogram. It has opposite sides parallel. It has opposite angles congruent, opposite sides congruent. It has all the qualities of a parallelogram, but the extra added bonus is that instead of it being like a traditional parallelogram where the opposite sides were congruent, all the sides are congruent. So all four sides are congruent. And there are two special properties of a rhombus, and those are regarding the diagonals. So the special properties of a rhombus is diagonals is that they are perpendicular to each other and that they bisect opposite angles. So what exactly do these words mean? So I tried my best to draw a rhombus. The diagonals being perpendicular means that the two diagonals cross each other and they form right angles. So all of these angles in the center, not just the two vertical angles that I just marked, but all of the angles in the center are 90-degree angles. And since we know that on a parallelogram the diagonals bisect each other, we still know that there's these relationships in here as well. So it still has all these qualities of a parallelogram, but now we also have these little right triangles inside of this rhombus. So the other key feature of the diagonals is that they bisect opposite angles. We know that opposite angles are across the figure from each other. So what that means is that these angles will all be congruent to each other because we knew that opposite angles are congruent, and we also know that the diagonals bisect them, so they cut them into two equal parts. So all of these opposite angles are cut in half to form basically four congruent angles. So another special parallelogram is a rectangle, and what separates a rectangle from other parallelograms is that it has four right angles, or four 90-degree angles. So four right angles. So a parallelogram can be a rectangle, but not necessarily every parallelogram is a rectangle. So it's got four right angles, just like any other parallelogram. It's got opposite sides parallel, opposite sides congruent. The diagonals bisect each other. And then there's a special detail, just like how a rhombus had special details about its diagonals. A rectangle also has a special property regarding its diagonals. So besides a rectangle having all the qualities of a parallelogram, it also has the 4 right angles, and its diagonals are congruent. So besides the diagonals bisecting each other or cutting themselves in half, this diagonal that I just drew is congruent or the same length to the diagonal that I just drew. So they cut each other in half and they're congruent, meaning that all the segments in there inside the rectangle are also congruent. Now, unlike a rhombus, and you can see in this picture, the diagonals are not perpendicular. You can see in this picture that the diagonals are not crossing at 90-degree angles, and that they don't bisect opposite angles either. You can see that these angles are different measures in here. Okay, so the last special parallelogram is a square. And a square is sort of like a rhombus and a rectangle combined. It has the qualities that a rectangle has, which is that it has 4 right angles or 4 90-degree angles. So that makes a square a special kind of parallelogram as well as a special kind of rectangle. And it also has 4 congruent sides. So you guys are probably familiar with squares already. We actually talked about squares when we talked about regular quadrilaterals, a 4-sided figure that has all sides and angles congruent. So a square is a special parallelogram, a special rhombus, and a special rectangle where it has both the qualities of a rhombus and a rectangle. So because it has both the qualities of a rhombus and a rectangle, it has the same special properties of the diagonals. Alright, so here is a picture of a square. It's got the qualities of a rectangle where it has 4 right angles, and it has the qualities of a rhombus where it has 4 congruent sides. And these special properties, like I mentioned, are the same as the special properties of a rhombus and a rectangle's diagonals. So the diagonals are perpendicular to each other. So here's an image of the diagonals being perpendicular to each other. All 4 of these angles in the middle of this shape are right angles, not just the one, because 2 perpendicular lines form 4 right angles, as we've talked about previously. The diagonals bisect opposite angles, so just like what happened in a rectangle, they bisect these angles. So this angle is congruent to this angle, and these 2 angles are also congruent to each other. So all 4 of those angles are congruent. And the diagonals are also congruent. So this line is congruent to this line, and these lines then are all congruent to each other. Okay, so take a look at this picture here. We've got right triangles here, just like how I mentioned in a rectangle that you've got right triangles inside of the figure. So you've got 4 right triangles, and not to mention, they are also isosceles right triangles because the sides, the 2 legs of these, would also be congruent. And then here's the hypotenuse. So I know these are kind of at an angle, but here are the 2 legs of your right triangle, and here's the hypotenuse. So you've got 4 isosceles right triangles making up this shape. So what do we know about isosceles right triangles? Well, we know that the 2 legs are congruent, right? And if the 2 legs are congruent, then that also means that the base angles should also be congruent. So if I've already used up 90 degrees in my triangle, I've got 90 degrees left over to split between these 2 angles, which means they're both 45 degrees. So this is a special right triangle. Now special right triangles are coming back into play when we're dealing with squares. We've got 4 45, 45, 90 triangles inside of a square. So because of that, the side lengths, the ratio of the side lengths are x, x, and x root 2. So we'll probably be using that when we deal with squares. Okay, so in summary, we already know about parallelograms. We know that their opposite sides are parallel, their opposite sides are congruent, their opposite angles are congruent, their consecutive angles are supplementary, and their diagonals bisect each other. So all parallelograms have those qualities. And then I just introduced to you 3 new special parallelograms. One of those special parallelograms is a rhombus. And what we mentioned before that makes a rhombus special, that sets it apart from other parallelograms, is that it has 4 congruent sides. Another special parallelogram is a rectangle, and what makes a rectangle special and sets it apart from other parallelograms is that it has all 4 right angles. And the last special parallelogram is a square. So squares are the most special because they have all properties of parallelograms as well as rectangles and rhombuses. So all squares are rectangles and all squares are rhombuses, but not all rhombuses are squares. Some can be squares, but not all. And some parallelograms can be squares. They can also be rhombuses or rectangles, but they certainly don't have to be.